Welcome back to the Algebra Alcove with your host, Mr. Pemberton. Episode 2, Systems of Equations, Substitution Method. In the substitution method, which is the second method for solving a system of equations that we will study, we are interested in combining the two equations together by substituting one equation into the other. Notice that both of these equations are solved for y. Y is equal to negative 7x minus 17. Y is also equal to negative 4x minus 8. Since both equations are both equal to y, it makes sense that both equations, or both of these algebra expressions, should be equal to each other as well. So that gives us negative 7x minus 17 is equal to negative 4x minus 8. And now we have an equation that we can solve for x and figure out the value for x because we know how to solve one variable equations. To solve for x, we will do the following. My first step is I'm going to move the x's over here to this side of the equation. So I have chosen to move the negative 4x by adding 4x to both sides. Combining the negative 7x and the positive 4x, I get negative 3x. The negative 17 still remains, equals. Notice the negative 4x and positive 4x cancel each other out, and we still are left with the negative 8. Now we have a two-step equation. We are going to add 17 to both sides. That leaves me with negative 3x on this side. Over here, negative 8 and a positive 17 makes a positive 9. And then we're going to divide both sides by negative 3. And that allows us to get x is equal to negative 3. Now that we know the value of x, we can take this answer and plug it into one of the two original equations. So I have chosen to take this equation and substitute my value for x into it. I could also have chosen the top equation as well, but since the bottom equation has smaller numbers, may be less likely to make mistakes. So by taking the second equation and substituting negative 3 for x, we get negative 4 times negative 3 is positive 12. Take away 8 gives me a y value of 4. Therefore, my final answer, the x value is negative 3. The y value is positive 4. This represents the point where the two lines would intersect each other had we graphed the two equations. Here is another substitution problem. Notice this problem, one of the equations is solved for y. The second one, y equals negative 4x minus 17. But the top equation is not. It is 8x plus 6y is equal to negative 22. We could solve the top equation for y and set the two equations equal to each other like we did in the previous example. However, a much quicker method is when one of the equations is solved for a variable, in this case, this equation is solved for y, we can go ahead and call this our substitution equation, in which we can take the algebra expression that y is equal to and replace it with the y in the other equation. So for the y here, in the 8x plus 6y equals negative 22 equation, I can replace the y with the expression negative 4x minus 17. Notice I put the expression in parentheses because I do need to be aware that the 6 was being multiplied by whatever y is. And now the 6 is being multiplied by everything here that represents y. We will distribute the 6 by multiplying 6 times negative 4, 6 times negative 17. That will give me 8x minus 24x minus 102 equals negative 22. Continuing to solve the equation, we combine the x's. 8x take away 24x combine together to make negative 16x minus the 102 is equal to negative 22. We now have a two-step equation that we can solve for x. By adding 102 to both sides, I get negative 16x is equal to 80. And then divide both sides by negative 16 to get the x by itself. X will be negative 5. Now that I know what the value of x is, I can go and find the value of y by returning to the substitution equation. My substitution equation was y equals negative 4x minus 17. That comes from the original problem, where we claim that we would use this as our substitution equation. So now what I'm going to do is plug in my value for x, and I will evaluate this expression to find the value of y. By plugging in negative 5 for x, I get negative 4 times negative 5 is equal to positive 20. Take away 17 leaves me with 3. So y is equal to 3. X is equal to negative 5. The solution to my system of equations is negative 5, 3, the x-coordinate going first, the y-coordinate going second. This has been episode 2 of the Algebra Alcove, hosted by Mr. Pemberton. In this video, we saw how to solve a system of equations using the substitution method. One method is to solve both equations for y and set them equal to each other. However, a second, much faster method is if one of the equations is already solved for a variable, we may substitute it into the other equation immediately and start to solve our problem. Thank you for watching.